EagleFeel is hosted in the cloud and built with cloud elements from Azure, making it highly available, scalable, and secure. The main objectives are to minimize COVID-19 spread, protect people from the virus exposure, rapidly detect positive cases, and provide COVID-19 intelligence. EagleFeel runs on Windows, macOS, Linux, both computers and laptops, mobile phones, both Android phones and iPhones, tablets and iPads. Let's start by understanding what a checkpoint is. A checkpoint could be any closed place where we could track who comes in and who gets out. For example, it could be an Uber, a bus, a train, an airplane, a bank, a mall, a restaurant, a room, a grocery shop, a hotel, a pharmacy, and the list goes on. How does a checkpoint function? At a checkpoint, we track who arrives at a specific location by checking those users in, and once they leave such location, we check them out. It's like a hotel. The same way you check in and check out from a hotel, the same way you would check in and check out from a checkpoint. Whether you go to a pharmacy for 10 minutes or you are in an airplane for 3 hours, we track how long you have been at a checkpoint. In order to understand how EagleFeel works, we will run a quick demonstration with more than 1,000 users so that we can see how it helps us protect from unnecessary virus exposure. Imagine the following scenario. We have a grocery shop which has 2 doors. We must ensure that people who have been sent to quarantine due to COVID-19 positive test results for any other reason obeys and does not enter our grocery shop. In other words, we will protect those people inside our grocery shop to not have direct contact with people who have been sent to quarantine for any reason. In the checkpoint tab, we will create a checkpoint. First, we will assign a checkpoint name. It could be as simple as Grocery Shop 86. Thereafter, we would assign some description. It could be where that grocery shop is located, or any more description we would like to add. Thereafter, we would add a space dimensions. It's pretty much what size this checkpoint would be. In this case, we would assign it 2 to 3 basketball courts, so it would be an approximate. After we create a checkpoint, we could see that we have been given a checkpoint ID and a checkpoint passcode. Since we have 2 doors, we need 2 devices to control this unique checkpoint. Now, we will copy and send the checkpoint ID to the other device as well as the checkpoint passcode. It's as simple as clicking on Join Checkpoint, copy-paste the checkpoint ID, and copy-paste the checkpoint passcode. Thereafter, we will just click on Join this checkpoint. As we can see, we have successfully synced both devices to the same checkpoint. Now we can cover both doors from our grocery shop. We are ready to check in and check out users. What we will do first is check in the administrators of the devices. Checking in users is as simple as asking for their identification, typing their identification, clicking on check-in. After that, we'll see a successful check-in alert. The same way from the other door, our other user would check in himself as well into the checkpoint we created, to which both devices are synced. As people arrive to our grocery shop, we start checking them in into the checkpoint we just created. It is as simple as asking for their ID and checking them in. Every single time we check the users in, we will get an alert whether it was a successful check-in or something went wrong. Let's say from door 1, we check in 4 users. Those users have ID from 105 to 108. As well, from the second door, let's say we check in 5 users, which have user IDs from 211 to 215. As we asked our user, he told us that his identification number was 212. Nonetheless, he's not registered into the system. Therefore, we get a not found alert. In order to register a new user, it is as simple as going to the New User tab, completing the form and clicking on Submit. If the user only wants to provide the ID, it's totally fine. We're not collecting user data. After that, we could go back to the Checkpoint tab and complete the check-in. We click on Check-in and we have successfully checked in our user with ID 212. We continue checking in the users that arrive. Now, when we hit the user ID 214, he's not registered as well. Again, we go to the user registration form. This user wants to provide more information and some contact information in case thereafter we have to contact him. So we take all that information, we complete the form and we click Submit. After that, we go back to our checkpoint and complete the check-in process. Once we click Check-in, we see that we have successfully checked in the user 214. Now, we continue checking in other users. Inside our grocery shop, there is a barber shop. So the person in charge of the barber shop would create a checkpoint as well. He would provide a checkpoint name, which would be barber shop, and he would provide some additional information. He could provide some description such that this barber shop is located inside our grocery shop. Thereafter, he would decide what is the space dimensions of that barber shop. It would be smaller than the grocery shop, about half size of a basketball court. Then he would click Register. Once the checkpoint is initialized, we're ready to check in and check out users from the barber shop inside our grocery shop. We can notice as well that our barber shop checkpoint ID is different from our grocery shop checkpoint ID, as well as the passcode ID. Some people that got into the grocery shop are going into the barber shop. So we ask their ID as they get into the barber shop. User 105 is checked in into the barber shop, as well as the two other users who did not have an account. User 212 and user 214 also get into the barber shop. As we see, we're not getting the not found alert because they are already registered. Now, when they get out of the barber shop, we just check them out. We type 212 and check it out, and as well as we type the user ID 214 and we check him out. As we see, we get an alert that they have been successfully checked out from the barber shop. Once they leave the barber shop, they might as well leave the grocery shop. So we would ask for their ID regardless to which door they go. User 212 goes to one door and user 214 goes to the other door. After that, we just click check out from both devices and they are successfully checked out from the grocery shop. We continue checking in users into the grocery shop as they arrive. User 250 attempts to get into the grocery shop through door number 1. The difference with user 250 and the previous users is that user 250 has been sent to quarantine for some reason. We don't care what reason it is that he has been sent to quarantine, but he must be in quarantine. So the system, as he attempts to get into the grocery shop, we will get an alert that this user must be in quarantine and that we have to avoid contact with him. As the user sees that he's not allowed into the grocery shop through door number 1, he goes to door number 2 and attempts to get into the grocery shop. At this point, it doesn't matter through which checkpoint you attempt to get into, because all the system is linked. Every single checkpoint you attempt to get into, it will display you the alert that this user must be in quarantine. As we attempt to check in other users into the checkpoint, the system will check whether that user is allowed to get into a specific location and whether he must be in quarantine. At this point, we have protected all people inside our grocery shop from users who are not obeying the quarantine they have been sent to. Now, imagine that you go to that grocery shop and then you go into the barber shop as well. A few days later, somebody who was inside that grocery shop and was as well into the barber shop tested positive. Then that person is asked, who have you had contact with? That COVID-19 user is not able to answer that question because he does not remember the exact and precise time he got into the barber shop and when he got out. As well, he just doesn't know everybody who was at that place. Here's another benefit from this solution. We could track the exact time who had contact with that COVID-19 user, and we could track what is the space dimensions of that grocery shop and the barber shop. We know that that user, to get into the barber shop, first got into the grocery shop. We can look into our grocery shop and look who has been at that grocery shop at that specific time our COVID-19 user was. We could filter that grocery shop by names and see who was in there. We can as well filter by email so that we can contact those users. Based on how much contact information you provided, we would reach out to you and let you know whether you had close contact with a COVID-19 user. You would not have to worry where have you been, how much time you spent at a specific location, and how big that location is. The chances of getting the virus are based on how long that COVID-19 user was inside our checkpoint and what the space dimensions of our checkpoint are. For example, we would calculate how long that person was inside of a checkpoint and what type of checkpoint it was. For example, if we look at the barber shop, it is a smaller space than the same grocery shop itself. So the chances of getting the virus are higher if you were inside the barber shop rather than inside the grocery shop. In other words, even though you don't present symptoms of COVID-19, you have been in close contact with somebody who tested positive for COVID-19, which means you're highly likely to have the virus itself even though you don't know it yet. So if you were planning to go to another place, it would be a good time to stay at home because you have been informed that you've been in close contact with a COVID-19 positive case. If you apply this solution everywhere, in an Uber, in a bus, in a train, an airplane, a bank, a mall, a restaurant, a room, a grocery shop, a hotel, a pharmacy, and everywhere else we could apply this solution, we could help minimize COVID-19 spread, protect people from COVID-19 exposure by shielding them against users who disobey quarantines, rapidly detect possible positive COVID-19 cases without even running a single test, provide users with COVID-19 intelligence to prevent further COVID-19 spread. We have seen cases in which one person spreads the virus to thousands of other people without even being aware of having the virus. We've also seen people who do not follow quarantines even when they have been tested positive for COVID-19. Please let me know what you guys think about this solution and whether you also believe it brings some value and will be used. To all of you out there, take care and thank you so much for your time.